Hello students, welcome back. I am Alejandro from Victory IB and CAIE Online Academy. During this video we will be discussing part A of problem number 2 of the 2019 AP Physics 1 exam. Now this problem, as well as the entire exam, is divided in subparts, so make sure you watch all the previous videos as well as the following videos to have a complete understanding of the concepts that are involved during this exam. Let's get started.
So problem number 2. It's a 12-point problem with a suggested time of 25 minutes. Let's introduce the problem. This problem explores how the relative masses of two blocks affect the acceleration of the blocks. Block A of mass ma rests on a horizontal tabletop. There is a negligible friction between block A and the tabletop. Okay, that means that the slightest amount of force will be able to accelerate block A. Block B of mass MB hangs from a light string that runs over a pulley and attaches to block A as shown above. The pulley has a negligible mass and spins with negligible friction about its axle. The blocks are released from rest. Part AI, you will be given 2 points for a correct resolution of this part. Only 2 points. Suppose the mass of block A is much greater than the mass of block B. That means we have a huge mass in here and a tiny mass in here. Estimate the magnitude of the acceleration of the blocks after release. And briefly explain your reasoning without deriving or using equations. Okay, this is the idea. If block M has a tiny mass compared to the one of A, it won't be able to produce much of an acceleration. Block A will have an acceleration because no matter how light block B moves, it will introduce a tension in the system that without having friction force between the block A and the tabletop, A will eventually gain some speed. So our explanation should describe something as the following. The acceleration will be small, will be negligible, will be almost zero, whatever you want to say. That's the idea. The acceleration after release will be negligible. But we need to explain that's a statement, right? This is because block A has large inertia and won't speed up much. That's it. Now, suppose the mass of block A is much less than the mass of block B, like the opposite situation, right? We have a large amount of mass in here, exactly the opposite situation. Giant, massive block B, and a tiny, light block A. Estimate the magnitude of the acceleration of the blocks after release. Briefly explain your reasoning without deriving or using equations. Okay, what's physically happening here now? Now, block M will be pushed downwards due to its own weight and will be pulled upwards with a tiny amount of force, a tiny amount of tension produced by the fact that block A is attached to the other end of the string. Now, If block B is really massive, at least compared to block A, it will experience something really close to falling freely. So what the acceleration that we expect to have is very similar to the acceleration that block B would have if there were no strings attached to it. And that acceleration is the acceleration due to gravity. Block B in this scenario will be moving downwards almost as if it were falling freely without any strings attached to it. So what is the magnitude of the acceleration? The acceleration of the blocks will be close to G. Due to the fact that the tension on the string will be small compared to the weight of B. Compared to the weight of B. Compared to the weight of block B. Great.
Okay, thanks for watching. This was part A of the second problem. Please watch my next video for the remaining part of the problem as well as the remaining part of the exam. Also, don't forget to register on our website www.victoryonlineacademy.com for a free demo registration. I'll see you on the next video.